Well, welcome to Science, everybody. When I was a sophomore in high school, as most of you folks are, I was fortunate enough to do a trip to Ireland. And when we got there, got to the first place we were staying, opened up the car door, and what was in the front lawn but a palm tree. Now, think about where palm trees live over here in the United States. And let's think about where Ireland lives latitude wise, because remember, latitude is like what determines how much sunlight you get and all that, right? So if we compare Ireland's latitude to what we're used to over here in North America, you can see it's way up here, like Hudson Bay. What's it like up there? What are the chances there being palm trees? Even if you go way south of Hudson Bay down to where we live in the Great Lakes, there's still no palm trees. You got to go way, 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 way south to get to where they are. So, how the heck are there palm trees growing in Ireland? Now, excuse me, to note, they're not native. They didn't evolve there, they didn't travel there naturally. They were brought by landscapers and put in. And apparently, as long as it doesn't freeze, they can survive year to year. However, still at that latitude, it's pretty impressive that it doesn't freeze. So the question becomes why? And the why is that there is a system of, this is a weird thing to say. It's always a weird thing to say. It's a weird thing to hear the first time, but it really is a good way of saying it. There are rivers within the ocean. There are large scale ocean currents that do a great job of distributing heat throughout the planet. Hopefully, we're deep enough in Earth science where you realize that between the tropics, the equatorial region is where the most energy is bombarding the Earth throughout all four seasons. And therefore, this is where it's hottest. And towards the poles is where it's coldest because there's the least solar energy. So there has to be some system to get some of this heat. Not cosmically, there has to be, but there is some system to distribute heat throughout the planet. And what they look like, this is actually two live images of it. Well, maybe yesterday. These were yesterday, where you can see this red's hot. This hot water catches this like it's a stream, it's a river, it's a current of water flowing up through into the colder northern Atlantic waters. Here's the northern part of northeast United States, Cape Cod, Long Island, and then up into Canada. And you can see that warm water working its way up, and it really continues and goes all the way over to Europe. All right, we're right through there. So just anecdotal stories. Ireland has palm trees. How about that? I got a quick video you're going to watch about catching tropical fish on Long Island. Um, Being into sailing and having sailing buddies. If you want to make it over to the Bahamas, you've got to cross across that jet stream. And it's if you try to do it like at this angle going into the stream, life's tough. It's tough enough going through this because it could be some pretty wild weather. Worse if the weather's coming from the north and the current's pushing out of the south, it flops you over. So it can be rough to cross this, and it's like 45 miles wide from what I read. So it can be a rough crossing. It's kind of like I don't know, something that it's like a sailor's rite of passage, literally. But you got to imagine that as you come out, if you're trying to go dead east, that this current's going to push you towards the north. So you got to deal with that as you navigate, as you set your sails and work your way through it. So, yeah, that's that. So, this heat is basically like a global conveyor belt system. This heat is brought up. It really is responsible. Look how far north, like all the rest of Europe, is up here, too. All of this waterway up here, which is like vital economically for shipping, receiving, keeping economies alive. If there isn't this North Atlantic current just constantly shoving warm water here, this is going to be a lot colder, kind of like it is over in this part of the world where there is not that constant stream of warm water. So consider what would happen to the economies of Northern Europe if that stream were to turn off, if it were to shut down. And unfortunately, with changing climate, they're noticing that as more fresh water dumps in this way, it is slowing down that current. All this circulation slowing down, which is not good at all for those folks over there and for the rest of the world. So yeah, that's that. So your job, if you go to the document that's in the thing there, is going to be to pop open a reference table, but the reference table is it's printed on the back. I'll just go to it in the actual reference table so you see where we're looking here. It's page 4 of the reference tables has all of these global conveyor systems. Hot water gathers near the equator and is shoved off towards the poles, and vice versa to complete the circulation. Water from the poles is pushed up towards the equator. They're bent sometimes, and this, we haven't really gotten into Coriolis Force yet, but one of the answers on that sheet, hint, hint, is Coriolis Force. Coriolis Force bends these large-scale patterns to the right in the northern hemisphere, making the gyres go this way, to the left in the southern hemisphere, making them go the opposite way. And this is only surface. If you really get into analyzing this, there's deep water ones for returns too, creating this whole entire interesting, cool, complicated global heat circulation system. Sound good? Time for glass. Good luck.